Hello, this is section 3.3. Okay, in this section, I will be talking about the derivative of a product and a quotient. So basically, I'll be talking about product and quotient rule. All right. So before I go into this, let me show you some examples first. Let's say if we have a function y is equals to 2 times x to the power 4. All right, and I want to take the derivative of this. So y prime, I can use power rule, right? Using power rule. Using power rule, I can say that I can, well, basically, here first, well, we know that there are two terms, right? One is 2 times, one is x to the power 4. One is a number, another one is a variable, right? An equation with a variable, right? So on this one, all we have to do here is just bring this 4 down here. So it's 2 times 4 x to the power. Now we get a new power, which is 4 minus 1, 3, right? So 4 times 2 is 8 times x to the power 3. All right, so on this one, we can use a power rule directly, right? Similarly, let's say if we have y is equals to now again two terms where these two terms are in terms of x. Now there are two variables, right? Here one is a number, one is a variable, but here both of these equation or both of these terms has a variable x, right? So in this case, well, we can combine these two, right? We can say x to the power when there are same base, then we can just combine this to single base and just multiply, sorry, just add the power. And then after this, I can take the derivative, which will be 7 times x to the power 7 minus 1 is 6, right? Okay, but here, well, something like this, if there are two terms and both has variable and both are multiplying to each other, then we have a thing called well, product rule. All right, so the product rule says that let's say we have a function and both of these equations are in terms of, or both of the terms are in terms of x. So let's say the first one is, let's say it's g of x times h of x. All right, so the equation which has two terms like this, and I want to take the derivative of this, then the derivative of this will be, okay, there are two terms multiplying to each other, then in this case the first one will be, I can take the derivative of one terms, either this one or this one. Let's say I want to take the derivative of this one, g prime of x. So if I take the derivative of this one, then the second term is going to stay the same. All right, plus now here I took the derivative of z, then on the second one I have to take the derivative of h. So take the derivative of h, and then g of x will stay the same. All right, so this is called product rule, right? So using this product rule, I can also find the derivative of this. Well, in this case, it's simple. Let's do another problem. Let's say another one, example 3. Let's say we have f of x is equals to 2x minus 7 times 3x squared plus 4. All right, so now I can use a product rule here. So using the product rule here, so well, there are two terms or two things, one inside the parenthesis, another also inside the parenthesis. Both of these are multiplying to each other, so I can assume that this is g of x, this is h of x, and follow this product rule. All right, so if I use the product rule here, the first thing I can do here is I can take the derivative of, well, I can take the derivative of this one or this one, doesn't matter. Let's just take the derivative of this one first. So if I take the derivative of this 2x minus 7, well, first let's just take the derivative of 2x, right? Well, if I take the derivative of 2x, there will be just 2, right? Because the derivative of x is just 1, right? Because if I take the derivative of x, then I can bring this 1 down here, x to the power 1 minus 1, which will just give 1 times x to the power 0, which is just 1, right? So derivative of x is just 1. And the derivative of a number is 0, all right? So I took the derivative of this first, then the second whole thing will stay the same. Plus, right? We have a plus here, so plus. Now, here we took the derivative of this first thing. So now here we're going to take the derivative of the second thing. So first one will stay the same. And if I take the derivative of the second one, now for here I have to take the derivative of 3x squared. So 3 times 2 times x to the power 2 minus 1 is just 1, right? So here now I can distribute this 2 to these two terms. So 6x squared plus 8, right? This is also 6x, right? So 6x plus 2x is 12x squared minus 6x, well, 6x times negative 7 is negative 42x. So 6 plus 12x squared is 18x squared minus 42x plus 8. All right, so you can leave your answer right here. You don't have to do anything else after this. All right. So similarly, let's say another one. Let's see if we have f of x is equals to 2 times x to the power 4 times e to the power 6. All right, now I'm going to take the derivative of this one. So again, there are two terms with x on each. So let's just say this is g of x. This is h of x. Then I can use a product rule here. So I'm going to take the derivative of this f of x. Then the first one, let's just take the derivative of this. So I can bring this 4 down here first. So 2 times 4 times x to the power 4 minus 1 is 3. So if I take the derivative of this one, the second one will stay the same. And then after that, now let's take the derivative of this second one. So the first one will stay the same. And the derivative of e to the power x is still e to the power x. Right, there you go. Well, I don't think I can do anything further. Well, I can just multiply these two. That's what I can do. So 8x to the power 3 e to the power x plus 2x to the power 4 e to the power x. Right. Similarly, let's see if I have f of x is equals to similarly here I can also say this is g of x, this is h of x, then first now I can take the derivative of this g of x, which will be 5 times 3 times x to the power 3 minus 1. So 3 minus 1 will give 2. And the second term will stay the same. Plus, the first term will be the same. And the derivative of natural log of x is, if you go back to yesterday lecture 3.2, 6 and 3.2, then the derivative of natural log of x is 1 over x, right? So after this, it looks like, well, I can just multiply these two, right? So which will be 15 x squared natural log of x plus this x cube on the top and this x on the bottom. I can cancel this. So on the top, we'll just have 5 times x to the power 2, or 5x squared. And yeah, that's all you can do. All right. And now this is how you're going to use a product rule. All right. Now the second one, quotient rule. So the quotient rule is basically, let's say if we have f of x is equals to x squared over 3x minus 1, right? And I want to take the derivative of this function. All right, so here we have a division, right? So in this kind of problem, now we can use a quotient rule. So the quotient rule says that, let's say if we have a function, again, on the top, let's say g of x, and on the bottom, h of x. I want to take the derivative of this. So f prime of x will be, so on this, on these kind of thing, okay, the first thing here we will do is, first you have to take the derivative of numerator. All right, so the numerator, take the derivative of that, and then the denominator will be the same. You don't change the denominator. Okay, first this minus, and after that, once you take the derivative of the numerator, now here you're going to take there will be minus. After this, you'll take the now derivative of denominator. So h prime of x, and now the numerator will stay the same. All right, and divide this whole thing by the square of the denominator. Whatever is there in the denominator, just take the square of that. All right, so this is called quotient rule. All right, so this is quotient rule. Okay, so using this quotient rule, I can find the derivative of this function here. So let's say, okay, so let's here say f prime of x is equals to, okay, so using this here, we take the derivative of numerator first, right? So the derivative of numerator is x squared is 2x to the power 2 minus 1 is just 1, right? So just 2x, and the second, well, the denominator will stay the same, right? Minus, now take the derivative of denominator. So if I take the derivative of denominator, 3x, so 3x first, 3x will be, well, the derivative of x is just 1, so just 3, and derivative of 1 or negative 1 will be 0. So yeah, we just get 3 from the denominator, and times numerator. So the numerator will stay the same. All right. And divide this whole thing by divide this whole thing by, okay, yeah, sorry, yeah, 3x minus 1. Take the square of the denominator. All right. All I'm doing here is using this. I'm just using this rule. All right. So then after this, I can just distribute this 2x to these two terms. So that will give 6x squared, right? Minus 2x minus 3x squared over 3x minus 1 square, right? And this is equals to, well, 6x squared minus 3x squared is 3x squared minus 2x, 3x plus 1 whole square. All right, that's all you can do. I don't think you can simplify anything further. Even if you do it, I don't think you'll get a simplified version. Okay, so yeah, this is a good stopping point. You can just stop here. All right. Okay, so now now let's do another example. Okay, this will be a last example. F of x is equals to natural log of x over 1 plus e to the power x. All right, so here, again, using quotient rule, first I have to take the derivative of numerator, right? So the natural derivative of natural log of x is 1 over x times the denominator 1 plus e to the power x minus, and then now the numerator will stay the same, and then we take the derivative of denominator. So first the derivative of 1 is 0. The derivative of e to the power x is still e to the power x. So times e to the power x. All right. Over, take the square of the denominator, 1 plus e to the power x. Okay, so I don't think you can, well, all you can do here is just combine these two, just, yeah, but I don't think, well, let's do it, yeah, but I don't think you will get any simplified answers, but okay, so here we have an x, so when we combine these two, we get 1 plus e to the power x minus x times natural log of x times e to the power x over x, right? And we still have this whole, the big division, divide this whole thing by, sorry, I should have taken the square of this, right? So 1 plus e to the power x and square of that. All right, so here well, it looks like, okay, if you again simplify this, well, all you can do is it will go to the bottom. So e to the power x minus x times natural log of x e to the power x, divide this whole thing by, okay, this will go to the bottom. So x times 1 plus e to the power x, 1 plus e to the power x square. So yeah, this one looks slightly better than this, right? So yeah, so it's always a good idea to simplify if you can. I'm not sure what Pearson really asks you to enter for these kind of problems, so it's a good idea to simplify if you can. All right, so But if you see there is no way you can simplify, then you can just stop there. All right. So yeah, this is it for this section 3.3. All right. So like I said, I think I've sent out the email to everyone, but I'm going to remind this again. So the homework, the Pearson homework, of section 3.2 and this section 3.3 will be due Sunday, this coming Sunday, I think, which is June 14. It will be due at midnight, 11:59 p.m. All right. Okay, so yeah, please start working on the homework as well. And I'll see you in the next video. All right. Thank you.